Now we're going to look at how to state the domain of a function. Here we're going to look at the function g, which is the square root of 4x minus 1. What we can do is we first go over to the calculator and I'm going to graph it. So I have it graphed here. Now the one thing we need to be careful of is when we look at a starting point, or an ending point for that matter, we need to make sure that the graph actually touches that point. The way to do so is if you do Control T, we can see a table, and that value looks like it's at 1. And you see how we have a real value there? It exists. That's where the domain will start. If I go to the value 0, you'll see it does not exist because all these values, the graph does not exist there. But starting at 1, we do have a graph. So what I'm going to do is I'm going to copy this over and I'm going to paste it in the smartboard. Now that I have this pasted, we can write our domain. It appears to me that it goes as far left as 1 and then agrees with the table. So we would say in set builder, and I'm just going to abbreviate, set builder, we would write it this way. We'd say that x will go from the value of 1, which is less than or equal to x, and this graph will go on forever. So you could put an infinity there. You actually don't have to. And these are an element of this as long as x is an element of the real numbers, because inside of here it hits fractions, it hits rationals, irrationals, everything in between. So that's how you'd write it in set builder. Now I prefer interval, and so you'll see me write an interval in the future. And so in interval notation, you just write it like this. The smallest number is 1. We can equal it, so I put a bracket, and this will go on until infinity with a parenthesis. Let's try another example. Here, state the domain of this function. Let's first go over and graph it. So we have the function 3t squared over t squared minus 1. So go to my graph, and I'm going to create a new document. This clears out everything else. And now I want a fraction, which you can do that by pressing Control Divide. And then I have 3, instead of using t, I'm going to put x squared on top over x squared minus 1. And here's my graph. And as you look, it seems there's a gap in some of these values. I'll press Control T to help us see them. I press Control T. I see that there's a gap. It looks like at 1 and also at -1. Let me double check real quick. Yep, those values are undefined. So now I have my picture. I'm going to take a quick picture, and I'm going to paste it over here. Now I'm just going to write an interval. It appears this graph goes on forever to the left. So I would start with negative infinity. Negative infinity will always have a parenthesis because it's not a real number, and it goes left forever. Now as this piece moves to the right, there's a break. That break occurs at -1. And I could check this by putting in an asymptote here. We should be able to have an asymptote right between those pieces there and another one right in between these pieces here at 1. So you can see it just divides the function. So that's the first piece. An asymptote, a vertical asymptote rather, will also always have a parenthesis. Now remember how from earlier, a u means another piece is coming, or the word or. This piece goes from -1 to 1. So I'll put that in from -1 to 1. And finally, we have one more piece from here to here. All right, so we would have a u, and this would be from 1 to infinity. That's an interval notation. Now on this one, this is one of the few problems that it might be easier in set builder, because you could say that x just simply does not equal -1 and 1. Other than those two values, x can be anything. All right, finally, we got one more. Now let's pull over, and for the sake of time, I'm just going to pull over the graph. Now that I have the graph pulled up, you can see that we have a curve going here. There is an asymptote in this problem. It does not cross that value +1. And how could I know that it's exactly 1? It's because I can look at the table and it says there's an error there. So the values start after. You're looking for anything that's hashtag UND for undefined or ERR for error. That's where it tells you you'll have a break. On this problem, we could say that the graph goes from 1 to infinity for my domain. Again, 1 a parenthesis because it's an asymptote, the infinity because infinity always has a parenthesis. And then in set builder, you could simply say that x must be greater than 1. All right, now you try.